So one of the cooler things, in my opinion, that we released at Automation Fair is this guy that Nick is holding here.
Power Puck.
It's called the Power Puck. And Nick and I were talking before we jumped on here about the weather.
Yeah, it's like, what, 10 degrees outside now?
Yeah.
So the cold weather, everyone knows, especially innovations in predictive maintenance, batteries are never anyone's favorite part of any equipment. So we've been looking into this company, and we acquired Perpetua this spring. But what it does is it's a thermal energy harvester, which is really cool, which is probably one of the most new innovative things that we saw at Automation Fair, and it's really nice to have in our booth.
Yep.
But what that's going to do is you can place that Power Puck on a warm surface, and it's going to take that and generate electricity. Enough for field transmitters, wireless devices to replace batteries. Yep. It's not going to generate enough to replace a hardwire, any 24-volt power. But for, say, Emerson or Rosemont wireless transmitters, if you want to put those out there, especially if it's in a class 1, div 1 kind of location, any hazardous install,
yep.
These are going to fit right in, and you're going to be able to self-power without running electricity, without going out and replacing a battery every couple months. It definitely caught attention.
Oh, 100%. And I think one of the most common questions we get with it is how much of a temperature differential do you need? And typically, if you can place your hand on a motor or pump and it's just warm to the touch, that should be plenty enough. But raw numbers, it's about 30 degrees Celsius is the temperature differential that you need from the surface of the motor or pump to the ambient air. And typically, these are very frequently installed in oil and gas applications where that is basically no problem to hit, is that temperature differential.
If you got a warm surface and wireless transmitters, what we've been seeing, so generally, the oil and gas has been the biggest user, the most established install base. But with using wireless transmitters, they generally have to bring down the data transfer rate that they do. And most of them are doing it once an hour. And you hear a lot of manufacturers suggest, like even ours, we suggest once an hour just to save some battery life and give it 5-10 years. But the operators and the machine users want the every minute, every few seconds if they can. So the Perpetua Power Puck is going to be able to support that. So if you have a warm surface, there is no battery to kill in this. As long as that temperature is there, there's power there, and we can perpetually, hence the name, perpetually power all these wireless devices. So Chevron using like a steam pipe is a way to power multiple of them. So when you look at the cost analysis of an install, if you take out the need to run power to a location, especially if it's hazardous, if you take out the need to go replace batteries every year or two, especially if it's hazardous or in an extreme height or anything like that, we can start knocking off near $10,000 of an install of a wireless transmitter, and you'll never have to go back and maintain a battery.
Yeah, the big thing here is typically a lot of these oil and gas applications too with these transmitters is they're hazardous locations, and it costs quite a bit of money to change a battery. So it's something as simple as a battery change. It can take quite a bit of time getting a work order, getting the proper permits to go change that battery to enter that hazardous location. So basically this prevents people having to go into a dangerous situation and just to change a battery. This allows, like Nick said, basically to power your transmitter almost indefinitely or for the life of the transmitter. And
20 years established life is what we're getting out of these. So 20 years of not replacing a battery is a lot of cost savings, a lot of labor savings, and a lot of peace of mind, especially if you're able to get the data you want.
Yeah, and recently I had a conversation with a end user about a few weeks ago or about a month ago. They actually had a temperature of 800 degrees Fahrenheit to 1,000 degrees Fahrenheit. So they were asking like, hey, that's pretty toasty. How can we make this work? Or what's the top range of temperature this thing works with? So what we can do is we actually have an extender where it's like a pipe mount where it's a U-shaped bar, and you can actually stick this at the end of that where it takes it off the surface a bit to reduce that temperature to make sure it's still going to work and going to get plenty of temperature differential if it's that high heat for sure.
Yeah, it's interesting. I'm excited to see where we're going to go with this. The first stop, what we're doing is integrating this in with our vibration and equipment. So we do condition monitoring, predictive maintenance, and this is what these devices look like. So the Power Puck is intrinsically safe. It is hazardous location install safe. We're bringing that capability into our vibration system as well. So Grace Sense, starting next year, will be able to go hazardous location, class 1, div 1, intrinsically safe. A lot of the updates, again, we have the Power Puck integrated in with the vibration node. So what that enables you to do is take your Power Puck with the vibration node built into it, place it on a warm motor where you're going to be monitoring vibration, and that will now be powered perpetually. You'll be able to gather vibration data however often you want it, never have to go back, wire any power, change a battery.
Yeah, and the big thing here is a lot of people have this many meetings or conversations about should we go wired or wireless for a lot of these predictive maintenance monitoring systems. And they ask, obviously with wired, you get supplied power. You don't really have to worry about it. You can take frequent update rates, etc. But it typically can maybe cost a little bit more, harder to install, wire, figure all that out really. And then wireless, it's really nice and conducive to just be able to place something on a motor or a pump, especially if it's a tough location. But the problem here is typically batteries don't do super hot in colder weather, and you have to change out battery and you have a less frequent update rate. So with our 2 new versions, the VBT without the Power Puck and then the VBT with the Power Puck integrated into it, is that the one with the Power Puck, you actually have a wireless and batteryless system.
And we extended the range of it so it can communicate further. And there's a lot of engineering focus in the GraceSense right now. And that is one of the things that we noticed at Automation Fair, is that for new innovations and for pushing the envelope, we're really starting to stand out. And I think the next couple product updates we go over are really going to highlight that. But GraceSense is getting a lot of focus, a lot of traction right now, and it's updating a lot.